Stout, TBA. We've gone through now kind of the introduction of SMRs with the fuel cycle. So we're going to take a look now at the commercial site from a TBA perspective. Mr. Stout he's a senior manager of SMR technology, managing small modular reactor projects for TBA. He has 28 years of experience in the nuclear industry, the Navy, uranium enrichment at USEC, nuclear recycling and DOE, now with TBA. So, Dan?
So it looks like I'm between us and lunch. So I also know the value of questions. So I'm going to try to move through and then offer some questions. This is one of those I can go through quickly. Most everybody here in this audience knows what TBA is, but I want to read the quote when the act came out. A corporation clothed with the power of government but possessed of the flexibility and initiative of a private enterprise. That sounds good. That sounds good.
Just keep saying it.
We act that way. But our mission is affordable electricity, economic development, environmental stewardship, and there's some other elements that go beyond that. You know, when our board of directors are sworn in, one of the things that's in their oath is that they support technology innovation, and that's where SMRs fit at TVA. And so, you know, that's part of our mission. We serve 7-state territory, 9 million people. Revenues in 2012, 11 billion, and 13,000 employees. So we're fairly good size. We articulated a vision, 2011, I think it was, to be one of the nation's leading providers of low-cost and cleaner energy by 2020. And you know, that vision has remained. We got a new chief executive officer, and he's sticking with the vision. That's a good thing. Yeah. And you know, you can see I made the one on the right-hand side there, more nuclear generation highlighted, and that's where I'm fit in this thing. But you know, in a bigger picture, we're reducing coal, we're increasing nuclear, we're increasing natural gas, and balancing out the portfolio from where it used to be, where it was more than 50% coal. So in the nuclear area, we have 6 operating nuclear plants, 3 Browns Ferry boiling water reactors. We have 2 at Sequoia, pressurized water reactors, and 1 operating at Watts Bar, and 1 under construction. And Watts Bar Unit 2 is scheduled to be operational in 2015. The Bellefonte project is approved by the board to go forward when Watts Bar Unit 2 is complete. We'll tell you that there's some reevaluation going on Bellefonte. We actually reduced staffing and you know, slowed the pace down there. And you know, there's a number of reasons why, but one of the keys is that the need for power is shifting out. You know, the ever-changing forecast of your need for power always changing, and that demand growth isn't materializing. The recession that we experienced in the last 5 years is bigger and deeper and taking longer to recover from, and it changed the behavior. The spike in natural gas prices of a few years ago and things like that have led to a lot of change in the electricity sector, and the large consumers of electricity have modified their behavior. They're not running their operations during peak power, and so the need to build generation is shifting out in time. So Clinch River project, right here at Oak Ridge, probably within 10 miles right here. So we're looking at licensing up to 4 reactors at this Clinch River site. So why are we looking at SMRs? You know, I just talked about it, the need for a more diversified generating portfolio, increased use of reliable, clean, low-cost energy. And, you know, in terms of next generation nuclear, we think this is a great opportunity, a great option. So I'm going to spend a fair amount of time on this slide, but these are the things that we see as attractive features of SMRs. And improved safety and security is a big one. It's hard to put a price tag on that value, but it's really important, especially post-Fukushima. And, you know, so with these reactors being underground, with a lot less reliance on active safety systems, it's far more passive. It's a clever design. It's orders of magnitude better in safety compared to larger light water reactors. Now, the proof's in the pudding. Babcock and Wilcox will have to do the analysis and provide that to the NRC. The NRC will do an independent review of that. But right now, we see that the likelihood of accidents, we've jumped orders of magnitude. In terms of security, I mean, these are being designed post 9/11. So they're underground. They've incorporated security features into design. And that's really important because the security staffing at the large light water reactors is a huge piece of our operating cost. I think there's potential to be able to have a workforce in security that can defend you against those same design basis threats, but do it with a lot less people because it's underground and you build security into the design. Improved grid resiliency. This is one, it seems like the latest buzzword, resiliency. But as we see the spread of renewable energy, the spread of distributed generation, the generation that's popping on the grid from non-utilities, the need to be able to place your generation assets at points where the grid needs that supply becomes more important. As renewables become a larger component of your generation, and the sun goes behind the cloud or the wind doesn't blow, you need to be able to have more flexible generation. And traditionally that's been just gas. Well, SMRs have some capabilities of load following, and if you're a utility that has an abundance of hydro, wind, etc., that load following capability is going to be of tremendous value. You know, we're designing and building these assets that are going to run for 60 years. Trust me, having flexibility has value. So, lower financing costs. This is one of the keys, and it goes hand in hand with the reduced construction time. But if you look at the economics of large light water reactors, a lot of it's driven around the duration of construction in that time period when the interest is accumulating, and until you can start to put the asset in service and generate profit. And so by driving more of the manufacturing into the factory setting so that you can reduce the construction time at the site and just the lower overall cost, that makes it more likely for a bank to give a loan and keep that total financing cost lower. So you get a lower interest rate and you're letting that interest accumulate for a shorter duration. One of the benefits of the modularization is the standardization that's going to take place. You're going to have these components being replicated in a factory setting with tighter tolerances, with repeatability. And when a robot makes part, it's pretty much identical every time. So that also leads to the improved standardization. And we're committed to that standardization. We don't want Clinch River to be unique. We want it to be part of a fleet. Smaller footprints. Again, it goes hand in hand with these accident analyses, but the hope is that we're going to be able to use SMRs to replace retiring coal plants and reuse the distribution. Now, it's going to be important. Are we going to be able to have a smaller emergency planning zone? Are we going to be able to be compatible with those industries that this plant becomes near? And that remains to be seen. It's a policy issue. From TVA's perspective, if the Babcock and Wilcox design shows us that the dose at the site boundary is less than it is 10 miles from a large light water reactor, well, then it's reasonable to not require any additional planning in that zone. So that zone can be reduced to the site boundary. Also, we're supportive of helping to establish a robust manufacturing base, creating good jobs. It's important to the economy. I'm not going to dwell on these. Jack Bailey, I saw his slides, so we had a little overlap. We're going to be able to, so he's going to cover this kind of stuff. The point I want to make out, 180 megawatts is one of the things that's important here. We talked about a lot of the safety features on the last slide, but these things are going to be able to stay safe with essentially no operator action for essentially 14 days. I mean, that's pretty remarkable. The layout, talk about this low profile. This thing looks more like a Walmart than a nuke plant. And a 38-acre site. When you're building it, you need a little bit more for laydown and stuff like that. And modular manufacturing, I talked about those benefits. So we're looking at the Clinch River site. So this is the Clinch River. Oak Ridge National Lab, it's kind of like right up, somewhere up in this area. And the river flows along this way, and this is the site. So, in fact, that's our construction trailer. This is where our meteorological tower is gathering data. And this is the road that you come in. We are adjacent to Department of Energy property. The Department of Energy is a likely customer for the output of this plant. We have a memorandum of understanding with DOE to explore the potential benefits of DOE buying clean, reliable energy from an SMR. I'll talk more about that. So out at the site, we're doing some infrastructure development. Some old roads existed from back in the Clinch River breeder reactor days, but they needed some improvement. So there's a lot more gravel down, and we made a parking lot, put in the trailer, stuff like that. We began site characterization activities a couple years ago. We've on the bottom, you're looking at the intake and the outflow areas. The left-hand side is the meteorological tower. On the right-hand side is a picture of core boring. In terms of where we are in that phase, we started the core boring activities earlier this summer, and we are this week starts the last shift where core boring is actually taking place. So it should be done about 10 days from now. And so that's the information that feeds into the seismic design. We're also doing the hydrology, so we understand the groundwater. In terms of licensing, we're using the 10 CFR Part 50 process, the old process, not the 10 CFR Part 52 process. So this is the old two-step rather than one-step. And there's a number of reasons, but we anticipate that there are going to be some opportunities to make some changes during construction, minor changes that will help save cost and things that mutually make sense. And the Part 50 process allows that to occur because you end up truing that up in your final safety analysis report. The NRC reviews that, and then you have a hearing after those changes are made. So it's built into the process. And some of the benefits of following this process is well, let me me say it this way, TVA doesn't want a one-off design. So what we expect to happen is that as our design gets tweaked, that becomes the final standard design informed by construction that all subsequent plans will deploy. B&W gets some benefit from that. They're informing their standard design with the lessons learned during construction of the first one. And we're committed to make sure that that information, that plan, that path is adhered to by all parties. The NRC is aware of that approach. They're keenly interested in it, and there's some challenges and trickiness in terms of going back to the laws and regulations and applying it, because some of these laws are old. But we've been in discussions with the NRC for a couple of years, and we're in alignment. So the schedule lays out something like this. The top bar is the activity that Babcock & Wilcox is performing, where they're pursuing a design certification under the Part 52 process. And TVA is pursuing a construction permit application under the Part 50 process. Now B&W plans to submit the design certification application about a year from now, in 2014. And we plan to submit our construction permit application a little less than 2 years from now, in the middle of 2015. And NRC review and approval is on the order of 3 years, and you get your construction permit. So we will have a subsequent operating license application that gets granted right before you start up the plant. So the work that's going on now is risk management. It's risk reduction. You know, we're watching the technology. B&W is going to talk about their plans associated with testing some of the newer components and stuff like that. We're watching those. I've traveled to some of those facilities. Regulatory certainty. We're working very closely with the NRC on pre-application activities, making sure that we're in alignment so that they're not surprised when they get our construction permit application. It's of the quality and completeness that enables them to accept it and get right on with the review. Project development certainty. I mean, that's a lot of the key elements of cost, schedule, risk. We're continuing to refine those plans. And then there's financial certainty. Well, what's the business case here? What are the customers willing to pay for cleaner, more reliable energy? We don't know yet, but we're in discussions. So all those are necessary to have the risk reduced before we reach a construction decision. So the Department of Energy presented this slide in February of 2013. And what we're working under is an initial phase, phase one, which is licensing support. So the Department of Energy has awarded a cooperative agreement to the B&W team that includes us. And so about half of what I spend, I get reimbursed back from the Department of Energy. Same with B&W. And so this is part of that $452 million that Congress authorized, and $101 million has been appropriated. So we're drawing down on that. And that isn't going to last forever. So that's phase one. What's going to exist to enable this business case to be developed? Don't know. But, I expect that the first of a kind costs are going to be high, and TVA electricity customers aren't the ones that should bear the risks associated with the first of a kind. So we need to figure out an acceptable approach to risk sharing and cost sharing that's going to make this first project happen. Well, some policy ideas are being thrown around here and there, but it's time to get those moving. And those are things that can address phase two, phase three. The first mover, the early adopters, the first half a dozen or so reactors. And then full-scale factory production, that won't require federal support. That's where you have an economic product, and it's cranking out there. The type of support that will be needed from the government there is on the policy side, not imposing undue restrictions from an export standpoint, things like that. So what's this look like in terms of specific programs and timing? Well, I've talked about the licensing technical support program. That's what we're under right now. And that supports reactor design and licensing of the reactor and the site. The first FOA was awarded in November of 2012. It was selected in November of 2012. But it took a few months to negotiate the cooperative agreement. So we didn't have the cooperative agreement until April 2013, this year. The second FOA got announced in March of 2013. They haven't selected yet. And there's still a negotiation that has to take place before they have a cooperative agreement with the second awardee. These things take time. So there was discussion on the enabling legislation for years before it actually happened. So if the schedule is to be maintained, it's time for that discussion and the initial formation of some kind of legislation that's going to support first movers and early adopters. And that first mover plant, one of its purposes is to serve like a model home for future buyers. You don't necessarily have to wait till it's built to kick the tires and see what it looks like, because participation along the way in terms of the licensing process, in terms of the fabrication of the components that are going to the first plant, a future customer can engage early in the process. So the learning curve. Most of you have heard about that. It was talked about this morning. What's it going to look like? Nobody really knows, but there is data and evidence. A Virginia-class submarine that Phil talked about is a great example. And so it exists, but being able to predict and map that curve is a bit more art than science. So is it going to be a 60% difference from here to here? Is it a 40%? Is it 80%? We have work to do to be able to understand the expected learning curve, what its shape is, what its delta is. But sharing in this risk is what I was talking about. And TVA is not going to bear all that. That's how it'll be. So we won't build the plant unless that's shared. Stu.
Yeah, Darren, I'm not sure how much you can talk about that. Is TVA open to other commercial partners for the Clinch River site?
Our current position is that we are not entertaining other equity owners in this project. It complicates things when you have other equity owners in our territory. So we are supportive of helping other utilities, even other countries, learn about SMR technology, empower, and be able to apply it for their deployment. So we're interested in this. We want to see this path to an nth-of-a-kind economical plan before we make a decision to build the first one. So having some kind of law passed that makes this happen, but doesn't address the nth of a kind, or take it to the nth of a kind, isn't good enough, because we don't want to build a plant and be the only plant. We got a couple minutes. So we want to be part of a fleet of successful reactors. So personally, I believe that there is a good potential for the government to be a customer of the first several reactors. SMRs can meet DOE and DOD critical facility electricity needs. And those needs, at the top of the list, is reliability. Something that isn't going to go down if you have a cyber attack or a bunch of tornadoes. So how can that be done? Well, today it's done with diesel generators and batteries. But if you've got a big load, 20 megawatts or something like that, some of these you know, computer servers and you know, today, we have a lot more bigger loads, a lot more computer systems chewing up electricity that need this enhanced reliability that's less vulnerable to intentional destructive acts or natural phenomena. So an SMR near one of those loads with that power supply, perhaps using underground transmission or things like that, can meet that need, and it doesn't even need to be refueled, you know, so you can meet it for long durations. So it's self-supporting, doesn't require off-site power. So that's one of the things that's unique to some of the SMR technologies. So M-Power reactor will keep on running if you have a large regional blackout. It doesn't rely on off-site power for safety. So it's less vulnerable. The underground and things like that help you on a number of the potential events that make you less reliable. Both DOE and DOD have some directives to have more clean energy. We're all familiar with that. They also have this reliability challenge, and you know, many of the base commanders out there are scrambling to come up with solutions. But right now, the law says they can build renewables. In fact, they have to. They have to build 25% renewable by 2025. Well, you'd all know how reliable those windmills and solar panels are to meet this mission-critical need. They don't. So their problems exacerbated, and they haven't figured out the solution yet. So well, some of them have, but they're not allowed to develop the solution. So what I'm suggesting is that we can help. We can help with the Clinch River project. And both TVA and B&W are willing to consider providing enhanced reliability to DOE facilities. So that's Y12 and Oak Ridge. But we're not going to pay for it. Someone else is going to have to pay for it because this is helping to meet a need that isn't ours. So it can be done with us owning the asset, being regulated by the Nuclear Regulatory Commission, not some of the other models that DOD has been looking at, where the reactor's on the base owned by them and who's going to regulate it. Get away from that. Stick with the model that we know works, utility-owned asset, NRC regulated, near the mission-critical load. And now, there's work to be done to define the details. You know, what's the voltage and frequency fluctuation that's allowed? You have this large regional blackout, and I've identified 30 megawatts mission critical. So all of a sudden, everything's black except for a few buildings at Y12 and a few buildings at ORNL. And now, have we solved? You know, what happens is you get some fluctuations in frequency and voltage. Are they good enough? Or, in other words, DOD needs to weigh in and say, these are my specs, these are my requirements. We can design it, but we're running out of time to be able to do that. Yes, sir.
Dan, I just got a quick question. I came out of the DOD arena down at Eglin Air Force Base, and I've already gotten calls as far back as a year ago about hardened SMRs as far as tactical strikes go to keep them operational. Is BMW, do you know if BMW is working on that type of design, or do you have any idea?
No. What is the requirement to defend against? What is hardened? Define it. And once somebody pays and defines requirements, we can design it. But right now it's talk with a potential customer, and so we're not doing it. I mean, I'm not. I don't think B&W.
Well, I'm thinking of AEDC. They're right in the middle of your area. That's one of the calls I got. So I'm wondering if any work has been thought of relative to hardening those and certain requirements. So that you answered my question.
We've thought about it, and we're not going to do any work until someone else pays for it. That's how we make money. If you're a customer and you decide to build a house in the middle of the woods where there's no power lines, you're going to get charged a fee to run the lines to your new house that's off the grid. If you want to build a factory that has 6 nines of reliability, you're going to pay for it. So, a lot of talk.
So your answer is AEDC, they need to define hardened targets.
Absolutely. Once that's defined, then maybe someone will develop a product that meets the need that they can sell.
Okay.
So I'm doing all this, and what I'm going to need is a power purchase agreement from the Department of Energy that's going to pay a premium for this clean, reliable energy that solves their problem. Some of the facilities at ORNL that have customers with three-letter acronyms, they want their data, and they want their data after the cyber attack. They want it, and they want it now. I'm sorry, the lights are out. And so you can solve the problem, but it requires investment. It's not in our charter to just make every customer have better and better and better reliability. What's in our charter is low-cost energy.
That answers my question.
So the conclusion, SMRs are consistent with TVA's vision to have cleaner, balanced electricity portfolio. They fit with our mission. We're helping with technology innovation. We view B&W's design as appropriate advancement in nuclear energy. It's not undue risk. Talked about already, the same kind of fuel. Fuel is one of those bugaboos that we're glad they didn't come up with something totally different. But innovative in many aspects, especially in safety. And we like that. We have a suitable site. We have a key customer that's interested right beside that site. And a lot of work remains to reduce those risks and decide if this is viable and if we're going to go build it. So that construction decision is still a couple of years away. SMRs offer us an attractive option for this safe, clean, reliable energy worthy of continued investment today. So before I open up the questions, I got two things that I just kind of wanted to talk about. You guys are key players in the non-proliferation community. Many of you have your day jobs is in that area. And if there were as many SMRs as there are SMR conferences, we'd have a proliferation issue. They're all on paper yet, even the B&W. Well, it's more than paper. It's an electron. A lot of our government policies and regulations were formulated back in the 1970s, 1980s. We imposed peaceful use restrictions and consent rights on everything we did. We were more than 90% of the global market for things like uranium enrichment. So we could do it. We could get away with it. And the rest of the country took it. And we made them do things. Like if the country decided it really, really wanted to do reprocessing, and we would make that really, really, really painful for policy reasons. Well, as we talked this morning, it's not a technical reason, it's a policy thing. And who's to say our policy is better than their policy and all that stuff? Well, that creates an issue. So a country that has made a policy decision to go do something like reprocessing has spent a lot of money trying to work around these restrictions that our government has imposed in terms of peaceful use, in terms of consent rights, things like that. I asked Bob about buying parts for the centrifuge plant and what that does to the economics. Well, he mentioned feed and withdrawal. I mean, we may have to have a different feed and withdrawal system if they're ever going to supply fuel to Wattsbar. And who's going to pay for that? Well, he had to cut bait and decide I need this feed and withdrawal system, and I got to be able to go build a plant. And I've got an issue. So we do things like run Paducah for a year, make a bunch of materials, so we don't have to rely on that. And these things are becoming real. The Davis-Bessey pressure vessel head got a big hole in it. They get a new pressure vessel. Well, new head. What if Watts Bar had the same problem? And Japan Steelworks sent that over here. Do you think we can use Watts Bar for trading? You know the answer. So, I think we're at a crossroads on SMRs. I understand there's been some thought put into what's the right answer in terms of export control. And I'm here to, just kind of lay it out there, in my opinion. But if we put consent rights on exported SMRs, that's the death sentence. Because a foreign country isn't going to allow that kind of thing to be built. They're going to say, we're not signing up for that. And you have sealed the deal, making the Korean reactor be the product of choice for other countries. That's just my 2 cents. So we're stuck in this old paradigm of what's important from proliferation. I suggest that you think about it differently. And if we want a seat at the table, if we want safer, more secure technologies being built globally rather than Russian barges or whatever, we need to not handicap U.S. industry to compete with federally farm government-backed industry. And this is one of those crucial elements today where decisions are being made on what is supposed to be our export policy. So those of you that are in that, I encourage you to weigh in. Thanks.
Questions from him?
Hey, Dave.
Yes, sir.
On your conclusion slide, you had, significant work remains on those things there. From your personal perspective, what are the 2 or 3 long poles in the tent that are within that? I mean, certainly NRC license, but what within that? What are our long poles?
On the technical design, you have things like control rod drive mechanisms that have to operate in this temperature and pressure environment. So they have some good design concepts, they have some testing facilities, they got some testing plans, those things are getting addressed. But I got an eye on it because crap happens in technology development, it's hard. So that's an example of one of the technical risks. On the policy side, or on the licensing side, I really care more about the ones that lead to cost. So, I'll hit 2. The O&M cost, driven by staffing. I talked about security staffing, the other one control room staffing. So the concept is to have a reactor that has, 1 reactor operator per unit, 1 senior reactor operator overseeing those 2 reactor operators, and another qualified, certified senior reactor operator in the plant. They can do head brakes or whatever, that kind of stuff. And that's reasonable, but that will probably require an exemption that the NRC has to evaluate. So are they going to be able to grant that exemption or not? I'd like to know before I commit to build a plant. So emergency planning zone, and we talk about that. That's another one of those critical areas. So there's been a lot of talk about it for a long, long time. The NRC is not to blame here, B&W and the others. They need to give the NRC staff a design so they can evaluate it. They need to have the calculations that show what the dose is at that site boundary. They have to have the probabilistic risk assessment done enough and handed over to staff so they can chew on it and analyze it and say, yep, I agree with those calculations. I agree with that. Yep, if that system helps that way, and that's going to take time. But those are the types of activities that are important to the business case if they're going to be able to get an order book. So I can see a path to units number 2, 3, 4, 5, 6, so I can build 1. So progress on this EPZ is one of those. So those are some of the big ones. Any others?
Question for you. Your slide, one of your earlier slides said you were looking at building up to 4. Couple questions. A, when will you make a decision as to what's the real number? B, at one point I thought it was 4 to 6. But has that changed, or is that just a rumor?
Well, once upon a time it was 6. And again, what's my power need? Well, it's not 6. What are my objectives? One of my objectives is to understand the incremental nature of deployment and the ability to better match that demand growth. So 4 accomplishes that. So we're licensing 4. Now, when's the decision get made? The answer is as late as possible. What we're going to be analyzing for our environmental report is, well, if we build them all at the same time, or if we built 2 and then followed it up 6, 7 years later by 2 more. And you analyze socioeconomic impacts, things like that, and you've bounded your worst case. So at the time you're making your construction decision, you'll have to be deciding, am I going to stop after 2 or keep going? And there's actually the ability to get some synergy if you made that decision 12 months into construction, and So you have to decide, am I going to blast the hole for units 3 and 4 when I'm doing unit 1 and 2, or am I going to wait? So there's some things you can do that enable the second decision to be more efficient or not. So we'll be doing all those trade-offs. Yes?
At what point do you anticipate needing the power purchase agreement?
Well, to keep our schedule, probably in the 2016 timeframe. That's around the time when our cost estimates are getting hammered out pretty well, and we're going to need the offtake being known to be able to make that decision to start ramping up significantly on things like procurement of components and then beginning of the site preparation and construction activities that you do in advance of getting your license so that you can continue to keep schedule. So current schedule and around the 2016 time.
We tried to work with the Energy and Commerce Committee because they had a bill, and they said, well, first we need you to send it over to CBO to have it scored, and it came back astronomical. But we're working with the lab. They didn't really give it a fair shot, so we'd like to continue to work on that and make sure that we can figure out a way to make it happen.
Yep, some of the key issues on the power purchase agreement is, from a business case, you'd like to spread those costs over 20 or 30 years, not have them bunched up. So DOE typically has a limit of 10 years. I don't know if that's legislative or policy, and then the scoring, one of those artifacts of our arcane system of budget. But right now that contract, all of it, for 30 years, it all comes back and counts as debt, or counts as scored. So that's a problem. Any other questions?